Good evening, everybody. This is Pavan Kumar. I'm a faculty at ESE Engineering Academy and I teach Geo-Technical Engineering. So today we're here to discuss about the preparation strategy for GATE and ESE regarding to the subject Geo-Technical Engineering. So if you see first, in this session we are going to discuss mainly about the weightage of the Geo-Technical Engineering with respect to the competitive examination, and how we have to approach towards this, and what are the various textbooks that you need to follow during your preparation. And I'm not going to dealing any about important questions or something in this session. In the next session, one more session, which is scheduled at tomorrow, the same time, we'll be discussing about the important questions. But in this session, we'll be discussing about the weightage analysis and important topics to be covered, and what is the syllabus of the GATE regarding to the examination, GATE examination. Okay, and one more thing, I did my masters from IIT Hyderabad with the same specialization as a Geo-Technical Engineering, and I was a student once who wrote the GATE examination, and my GATE rank was a 600. So with respect to the due knowledge of the student and with respect to the past 7 years of experience towards the Geo-Technical Engineering teaching orientation with respect to GATE and ESE, we'll be see the weightage analysis first. Okay, so yeah, good evening everybody. First of all, before going to the weightage analysis, first of all we see the syllabus that was given in the IISc Bangalore website. The GATE 2024 is going to be conducted by the IISc Bangalore. So there might be some additions, there might be some deletions with respect to the syllabus. And there I'll be explaining what is the extra things that we needed to focus for the ESE, Engineering Service Examination also. Okay, so first if you see the syllabus, so there is a section 3 which was given in the IISc Bangalore, the syllabus module. In the syllabus module for the technical civil engineering, in the section 3, Geo-Technical Engineering, the Geo-Technical Engineering comprises of two parts, soil mechanics and foundation engineering. If you see the syllabus goes as first one as a three-phase system and phase relationships, which we have been teaching either in the offline classes or in the recorded versions as chapter number 2, which is basic definitions and physical properties of the soil. And then index properties, that is once again a separate chapter which is known as index properties. Unified and Indian Standard Soil Classification System, that is one chapter, the classification of the soils. Permeability, that's one chapter. In the permeability, we discussed about the one-dimensional flow, which is given by the Darcy. Seepage through the soils, two-dimensional flows, flow nets, uplift pressure, piping, capillarity, seepage force. So this entire, the permeability chapter, whatever the discussion that is present from here, permeability and this seepage through the soils, we discuss about this in the case of a permeability chapter. From the two-dimensional flow analysis, flow nets, uplift pressure, piping, capillarity, seepage force, we discussed about with the one chapter which is known as seepage pressure and seepage analysis. And principle of the effective stress and quicksand condition, we discussed in effective stress topic. Then we discussed about the compaction of the soils, which is again one chapter. And one-dimensional consolidation, time rate of consolidation, from the one-dimensional consolidation, time rate of consolidation, shear strength. So you see the one-dimensional consolidation and time rate of consolidation will be comprising in one chapter known as consolidation. And then the shear strength, Mohr circle, effective and total strength parameters, stress strain characteristics of clays and sand, and stress paths, that we discuss in one chapter known as shear strength. So overall, if you see in the soil mechanics, whatever the given data, we are going to give in a format, in a sequential order, whether the delivery is in offline sessions or online sessions or recorded versions. So in ESE engineering platform, we have moduled in a sequence, and in the soil mechanics, the entire data will be collected in chapters as first physical properties and basic definitions, next index properties, next soil classification, next permeability, next effective stress, and then seepage pressure and seepage analysis, and then we discussed about the compaction, consolidation and shear strength. So these are the things that we deal in the soil mechanics, and that is the syllabus given in the IISc Bangalore also. There is no much of addition over here. If you see in the GATE 2023, in GATE 2022 also, from the last 2 years, they excluded 2 topics from the soil mechanics. And what are those 2 topics are? Number 1, origin of the soils. The topic is excluded. Prior to 2021, GATE 2021, that topic was there in the GATE examination also. But now it is excluded from the GATE examination. And one more topic is soil structure and mineralogy. The soil structure and mineralogy, it was present earlier but not now. But mind you, if you are a graduate and who are writing for ESE examination also, engineering service examination, mind you, for engineering service examinations, the origin of the soil and structure, soil structure, those are the extra topics that you need to prepare. You don't need to prepare that for the GATE examination. But if you want to have very good exposure towards the soil mechanics and foundation engineering, so whether you study for the competitive examination or not, you must be having some exposure how the soil has been originated and what is the type of a structure for the soil and what are the mineralogies also. Right. Now, come to the next one. If you see the foundation engineering, the subsurface investigations, drilling boreholes, sampling, these all the sampling, subsurface investigation, drilling borehole sampling, plate load and standard penetration, cone penetration test, we'll be discussing in one chapter known as a soil exploration. We'll be discussing everything in one chapter known as a soil exploration. And then earth pressure theories, which consists of Rankine's and Coulomb's theory. That is one chapter which is known as earth pressure theories. Stability of slopes, where you're going to find out the factor of safety for the finite slopes and infinite slopes. Finite and infinite slopes, Bishop's method, and these all comes under in the case of the stability of the slopes chapter. You see the stress distribution in the soils, which is a Bosni's theory, pressure bulbs. The stress distribution in the soils, Bosni's theory and pressure bulbs. These are the things that I have already included in the soil mechanics, because the stress distribution in soil that comes under the soil mechanics. And one more thing, what I want to mention over here is, in the stress distribution, there are various methods. And in the various methods, earlier there was a Bosni's theory, Westergaard's theory, Newmark's chart, Newmark's methodology, lot of things were there. But now, the stress distribution in soils is only Bosni's theory and the pressure bulbs. We don't need to discuss about the Westergaard's theory. We don't need to worry about the Westergaard's theory. You have to study only the pressure bulbs and the Bosni's theory. That is in a stress distribution in the soils due to the vertical loads. And then shallow foundations. Shallow foundations may Terzaghi, Meyerhoff bearing capacity theories, effect of water table, combined footing, raft foundation, contact pressure, settlement analysis, sands and clays. From the shallow foundation, from here to here, everything we'll be discussing in the bearing capacity of the soils. And deep foundations, in the case of the deep foundations, dynamic and static formulae, axial load capacity of the piles in sands and clays, pile load test, pile under lateral loading. Yes, this is one of the extra topic that has been added. Again, from GATE 2022 onwards, in GATE 2022, 23 and now GATE 2024. So from the past 2 years, so they have added, means they are following the same syllabus. Every IIT is following the same syllabus. The pile under lateral loading, pile group efficiency and negative skin friction. So this all covers in the case of the GATE examination, foundation engineering. Okay, but let me conclude this. What are the chapters that are present in the foundation engineering is soil exploration, earth pressure theories, stability of the slopes, bearing capacity, pile foundations. Only 5 chapters. 5 chapters that are present in the foundation engineering and remaining chapters that are present in the soil mechanics. So let me write down in terms of a sequential order how to prepare for the examination for this geotechnical engineering. If you see, so geotechnical engineering syllabus, number 1, origin of soils. This is only for ESE. Only ESE. Number 2, physical properties and basic definitions. In this chapter, we'll be dealing the volumetric relationships and phase relationships. Next, number 3, soil structure and mineralogy. These also again only for ESE, not for GATE. So these two topics are excluded from the GATE but included in the ESE. And fourth one as index properties, fifth one as soil classification, and sixth chapter as permeability. Sixth chapter permeability. Seventh chapter effective stress. Eighth chapter seepage pressure, where we discussed about the quicksand condition and all. Ninth chapter seepage analysis, where we discussed about the flow nets, earth dams, flow nets and all. 10th chapter stress distribution in the soils, just now we discussed in the Bosni's theory, stress distribution in soils, that's a 10th chapter. 11th chapter that comes under as a consolidation. So Terzaghi is one-dimensional consolidation and what is the time rate of consolidation. 12th chapter that comes under as a compaction. 13th chapter that comes under as a shear strength. So shear strength is a very, very, very important and very big topic also. So these are all the chapters which we are going to deal. So if you have already prepared and if you are preparing, fine, these are the chapters. But out of these 13 chapters, I am telling you, the first chapter and the third chapter, they are not included. They are not included for the GATE. For GATE point of view, these chapters are not included. For ESE point of view only they are included. Apart from that, remaining 11 topics are included for the GATE examination. Okay, so this is a syllabus of soil mechanics. This is a syllabus of the soil mechanics. Mind it, these are the chapters from the soil mechanics. And from the foundation engineering, if you see, in the case of the foundation engineering, earth pressure theories, next, stability of slopes, next, bearing capacity, which is also known as shallow foundation, pile foundations, and last chapter as a soil exploration. Soil exploration. Okay, so these are the syllabuses that are related to the. These are the syllabuses that are. These are the syllabuses that are related to. If you observe, with respect to the GATE point of view. So up to for the GATE point of view, total 18 chapters, and in the 18 chapters also, first chapter and third chapter is not included. But apart from this, there is something extra syllabus that is there for the ESE examination also. In the case of the ESE examination, extra topics for ESE, Engineering Service Examinations, that is chapter number 19, Foundations on, okay, so this was not there now. Chapter number 19, Ground Improvement Techniques and geosynthetics. Ground improvement techniques and geosynthetics. These are the two extra topics that are required for the ESE examination, whereas ground improvement techniques and geosynthetics. So the ESE syllabus is more or less same, they will not change much. But for the GATE examination, they will add or delete. So deletion is chapter number 1, origin of soil, chapter number 3, soil structure. Addition is one topic in the case of the deep foundations, where that is known as a pile under lateral loading. But so far and so good. They haven't asked any question in the previous examination. Yeah, good evening everybody. Yes, I hope you people are preparing well. Okay, now, so this is about the syllabus pattern. And now, sir, what is the weightage analysis? This is about the syllabus, but what is the weightage of the geotechnical engineering and what are the important topics that to be covered? If you see the weightage in the case of the GATE and ESE, the weightage analysis, in the case of the GATE, in the case of the GATE examination, you take the trend of the past years, 2017, 18, 19, 20, 21, 22, 23, so far and so good. Whether it is a paper 1 or paper 2. I don't say the maximum or minimum marks. Average 14 marks. Average 14 marks. On an average of 4 1-mark questions, 5 2-mark questions. On an average of 4 1-mark questions and 5 2-mark questions. Sometimes they have asked 4 1-mark and 6 2 marks. Then the weightage is 16. Sometimes they asked 5 1-marks and 5 2 marks. Then the weightage average is 15 marks. Sometimes they ask 5 1-mark question, 4 2 marks questions, which is nothing but the 5 1-mark and 4 2 marks question, that is 13 marks. Okay, so that's the reason why I'm saying you average of 14 marks. You don't need to worry about whether it is 15 or 16. If you get the 15 marks, fine. Sometimes you may get 13 marks also, but if you see the recent years, in GATE 2023, set 1, set 2, 14, 14. GATE 2022, set 1, 14 marks, set 2, 15 marks. GATE 2021, set 1, 15 marks, set 2, 14 marks. Especially from the trend of 2020, 2020, 2021, 2022, 2023, last 4 years, in both the sets, there was no paper having a weightage less than 14 marks. So that's why I'm taking the average of 14 marks over here. So out of the 14 marks, 4 questions as 1-mark questions, 5 questions as a 2 marks question. Sometimes reverse, then it becomes 13 marks also. Sometimes 5 1-mark and 5 2 marks. Okay, so this is about the GATE weightage analysis. But if you see in the case of the ESE, in case of ESE, on average of again 15 questions. So there are some years where you can expect 13 questions. Some years they expect 20 questions. Some years we got 16 questions. Some years we got 12 questions. But on average of 15 questions. So if you write, you can write as a 13 to 18 questions. And here also you can write 13 to 15 marks. Okay, that's, I'm just giving you the variation, minimum and maximum. So 15 questions. And anyways, you know, in the case of this is in the case of the ESE prelims, I'm saying you. Right now we focus more on the ESE prelims, not on the ESE mains. So 15 questions, which is nothing but 30 marks. Each question carries 2 marks. More or less, can I say, in terms of the weightage, you see, this is 14 marks out of 70 marks of technical. Right? 14 marks out of 17 marks, which is 20% of total core. That much important it is. In the case of the GATE examination, you are going to expect 20% of your total questions from the GATE in the case of the geotechnical engineering only. 20%, whether you like the subject or not, if you want to get very good GATE rank, if you want to place in the NIT or IIT or any premier institutes, if you want to join any public sector units, you need to get very good GATE rank. For that, whether you like the subject or not, you must have to study the geotechnical engineering, period. There is no option for you. Sir, can I skip the geotechnical engineering? Yes, you can. At the same time, you can skip your seat in the IITs and NITs also. I don't say that you don't get the IITs and NITs, but if you study this one, you can get the premier institutes, the old IITs and very good NITs, where you can get a proper amount of the placements also. So even though you want to become a structural engineer, even though you want to study structures in IISc Bangalore or IIT Bombay, you have to study the geotechnical engineering. So that much weightage is there for the geotechnical engineering because it consists of both soil mechanics and foundation engineering. Okay. Whereas if you see in the case of the ESE prelims, every subject is more or less having a same weightage, which means in this case 15 questions out of 150 questions, right? So this is 10% of total core subjects. Okay, so this is a weightage analysis if you see for the GATE point of view and for the ESE point of view. And now, okay, fine, we are done with the weightage analysis and we are done with the GATE weightage analysis for the GATE and ESE. Now, if you see, out of all the subjects, for the GATE point of view, what are the subjects that you need to give preference? So, if you see the pattern of the previous year's GATE questions, from the last few years, every chapter we have provided a sequential order of the previous GATE questions. And from that, the more weightage topics are. So if you see in this case, the physical properties, index properties, permeability, this is very, very, very important. Next, this effective stress, seepage pressure and seepage analysis. Effective stress, seepage pressure and seepage analysis. Actually, from the effective stress, you don't get the questions directly. Why, sir? Sir, without effective stress, you cannot find out anything in the consolidation. Without effective stress, you cannot find anything in the shear strength. Without effective stress, you cannot do anything in the bearing capacity. So simply, I can say that effective stress already included. The effective stress is already included. So if you want to understand, if you want to understand the consolidation shear strength, you must have to study the effective stress. And these two chapters, they are important: seepage pressure, seepage analysis, and then consolidation topic, and then shear strength topic. This is very, very, very important topic, shear strength topic. And coming to the topics from the GATE, from the foundation engineering, you can see the bearing capacity, you can see the pile foundations. At the same time, you can see the earth pressure theories. Especially in GATE 2023, in set 2, they asked two marks questions from especially earth pressure theories. In the recent years, they're asking more questions from the earth pressure theories. Last year, in set 1 2 marks question, set 2 2 marks question. Previous year, in one of the set 2 marks question appeared, in one set 1 mark question appeared. This year, in set 1 2 marks question, in set 2 2 marks questions, especially from the earth pressure theories. You know what? Only 5 chapters from the foundation engineering and 13 chapters from the soil mechanics. But these 3 chapters bearing a weightage of minimum to minimum of 5 marks. Minimum to minimum of 5 marks. These 3 chapters bearing 5 marks, which is bearing capacity, pile foundation and earth pressure theories. 5 marks minimum, maximum of 6 marks, which means 2 1 mark questions, 1 1 mark question, 2 2 marks questions, or 3 2 marks questions. So from these 3 chapters itself, you can expect 5 to 6 marks. That much important these 3 chapters are. So don't neglect the foundation engineering part, where you are going to expect a minimum to minimum of 5 to 6 marks. Minimum to minimum, I am telling you. And I'm not looking over the stability of slopes. They may be asking once in a year or twice, alternatively or somewhere. And soil exploration, that's also a topic where the examiner would be asking very rarely, okay? But you would be getting the questions from this one, 5 to 6 marks. And if you see, these are two topics, compaction and consolidation. From these topics, minimum to minimum, you will be getting 2 to 3 marks. From these topics, you can get, not 2 to 3 marks, 3 to 4 marks you will be getting from the consolidation. So you can observe this is from here, 3 to 4 marks. There itself, we have covered 8 to 10 marks. 8 to 10 marks has been covered from these two chapters. Consolidation, shear strength, earth pressure theories, bearing capacity, pile foundations. Mind you, if you want to get very good GATE rank, you have to focus on these chapters: consolidation, shear strength, earth pressure theories, bearing capacity, pile foundations. 5 chapters. But the litigation over here is, if you want to understand the consolidation, shear strength, you must have to study the effective stress. If you want to understand the consolidation, shear strength, you must have to study the effective stress. So that's why you may or may not get direct question from the effective stress, but effective stress for the application of the effective stress is consolidation, shear strength, bearing capacity. So if you get a question consolidation, that's a function of effective stress. Shear strength, that's a function of effective stress. Bearing capacity, that's a function of effective stress. Okay? And from the CPS pressure and analysis, you can expect 1 to 2 marks over here. 1 to 2 marks you can expect from the CPS pressure, CPS analysis. And whereas in the case of the permeability also, you can expect 1 to 2 marks. You can expect 1 to 2 marks. And whereas from the case of the physical properties and index properties, physical and index properties, I'm saying this combination, the physical and index properties. So if you see the combination of these two, that will be getting again 1 to 2 marks. 1 to 2 marks. So there itself I have done the weightage of 1 plus 1, 2, plus 3, 5, plus 10, 5. 10 marks minimum and maximum of 2 plus 4, 6, 6 plus 2, 8 plus 6, 14 marks. 14 marks. So the total is of 18 chapters. In that 18 chapters, for the GATE point of view, neglect the chapter number 1 and neglect the chapter number 3. 16 chapters. In the 16 chapters, if you prepare half of those chapters, what are the half of those chapters? Physical properties, index properties 2, permeability 3, CPS pressure and CPS analysis 4, consolidation 5, shear strength 6, earth pressure theory 7, bearing capacity 5, 6, this is a 7 and 8. Yeah, these are 3 chapters and these 2 chapters 5 and this is a 6, 7, 8, 9. You prepare 9 chapters out of the 16 chapters, you get very, very, very good GATE rank. You can expect very good marks from the Geo-Tech. And at least 5 chapters you have to study before you're reaching your examination. So those 5 chapters are consolidation, shear strength, earth pressure theories, bearing capacity and pile foundations. This is for the GATE point of view I'm saying. For the GATE point of view. So what about ESE, sir? In engineering services, there is no important chapter, there is no unimportant chapter. You have to study all together from starting to the ending. First chapter say, last chapter tak. For ESE, 20 chapters you can get the questions from any chapter. Because 15 questions, they will be probably taking the weightage for each and every topic. And the unforeseen pattern that they are focusing in the past, previous years, in the last 2 to 3 years. So the GATE, the ESE paper board, they are following one pattern, the UPSC pattern. That pattern, what they are following is, so whatever the topics they are covering for the ESE prelims, they are not touching those topics for the ESE mains. In ESE prelims, they are taking some topics like some 7 or 8 chapters, or let's say some 10 chapters out of the 20 chapters. From the 10 chapters, they are giving 15 questions. But so the next mains examination, whatever the topics that covered in the prelims, apart from those, the leftover topics they are asking more number of questions in the mains examination. So that was a pattern followed in the last 2 to 3 years. We don't know whether the paper setter is going to be follow the same pattern or not, but nevertheless, we have to give a benefit of doubt. Prepare for 20 chapters for the engineering service examination. So if you get one half, you get the prelims. Obviously, you have prepared for 20 chapters. You have to go for the mains. Okay. So for the engineering service people, it is not a cool journey. It is a very long journey that you need to travel. You have to focus on each and every topic. For the GATE point of view, and is a more over the concept oriented. So from the previous patterns, these are the strategy that you can follow. Okay. So now that's about the syllabus, and I have explained you what are the topics that you need to focus more, which is nothing but these are topics. And if you see in the case of the topics, yeah, so that's about the syllabus. This is about the important topics, and this is about the weightage analysis of the geotechnical engineering. And we can expect, let me give you what are the type of models that one can expect from the very important topics like permeability, consolidation, shear strength, earth pressure theories, bearing capacity, and pile foundations. Topics that can be asked. So in the case of the permeability, majority of the questions that been appeared in the permeability is asking about flow passing through the anisotropic soils. Flow passing through the anisotropic soils. In the case of anisotropic soils, the majority of the questions that I have asked is, if you take anisotropic soil, which is having a different permeabilities, K1, K2, with the thicknesses Z1, Z2. So majority of the previous GATE questions appeared from the permeability topic is to find out what happens when flow is parallel to the bedding plane. Whatever this is nothing but the bedding plane. Whatever this is nothing but the bedding plane. Whenever the flow happens perpendicular to the bedding plane, and whenever the flow happens parallel to the bedding plane, this is perpendicular to the bedding plane, and this is parallel to the bedding plane. So majority of the questions that have been appeared in the permeability chapter is the flow parallel to the bedding plane and perpendicular to the bedding plane. So whenever flow parallel to the bedding plane, the average permeability is Kx, which is nothing but the weighted average, sigma Kz by sigma Z. That is the weighted average. But they ask more number of questions based on the flow perpendicular to bedding planes. If you see the flow perpendicular to the bedding planes, whatever the flow that is perpendicular to the bedding planes, in the case of the flow perpendicular to the bedding planes, so Ky is summation of Z by summation of Z by K. That is the flow perpendicular to the bedding planes, flow parallel to the bedding planes and flow perpendicular to the bedding planes. Okay, so this is a topic where they will be asking more number of questions. Topic number 1. And second topic is, so how to find out the flow rate passing through a soil mass, and what is the time required for the time travel. Okay, so the second one is they can ask you to find out the flow rate passing through the soil, which is nothing but Q Kia, and time required to travel from one point to another. So suppose if this is a point and this is a point number 2, and if the distance from this point to this point is L, then what is the time taken by the water? The time is nothing but, so velocity is equals to distance by time, and time is equals to L by velocity. Which velocity? C phase velocity. Mind you, to find out the C phase loss rate, So they give you the data, they'll ask you find out the seepage loss rate. In the case of the seepage loss rate, so they'll ask you to find out what is the seepage loss rate. You can find it as a Q Kia. Q is equals to KIA, where K is nothing but the coefficient of the permeability, I hydraulic gradient, and A, which is a cross-sectional flow area. Number 2, if there is a flow from one point to another point, what is the time taken by the water? That depends upon the seepage velocity Vs. And you know that seepage velocity Vs is equals to discharge velocity by porosity. So these are the two models, these are the three models I can say. One is the flow in the anisotropic soils. This is flow in anisotropic soils. And whenever the flow passing through the isotropic or any other soil, Q Kia, seepage loss rate, and how to find out the time. So these are the three models majorly they're asking in the permeability chapter. I hope this session is helpful for you people. So do comment so that I'll get to know. And if you have any other doubts also, you can ask me. Right now, whoever the people are watching, so if you have any doubts also, you can ask me. Is this session is helpful for you? Yeah. So if at all, if it is helpful, do comment. Okay. Now, in the case of the permeability, these are the topics. Now, similarly, if you see the consolidation topic, in the case of the consolidation, yeah. Okay, so this is about the permeability, and in the case of the consolidation, the type of questions that we can expect from the consolidation is, first one is to find out the ultimate settlement. To find out the ultimate settlement. So ultimate settlement is SF is equals to CC by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. From the consolidation in the previous years, they can ask you, if a building is constructed on a compressible clay layer, they'll give you the properties of the soil. What is the ultimate settlement? Or what is the consolidation settlement? What is the maximum settlement? Or what is the final settlement? So we have our various equations with respect to MV, quotient of compressibility, AV, quotient of AV, quotient of compressibility, MV, coefficient of volumetric compressibility, CC, compression index. For all practical applications, for engineering calculations, we prefer CC. So what is the CC? That is known as the compression index. The CC is known as a compression index, whereas E naught is known as the initial void ratio. H is the thickness of the initial compressible clay layer. So if you see, this is a foundation that is constructed in a compressible clay layer. Let's say this is the clay layer and there is some hard strata. Actually, the foundation applied, the load will act through the bottom of the foundation in the case of the shallow foundations. So what is the actual thickness of the clay layer which is under compression? That though the total is a clay, we don't see it as a total clay. We do observe from here to here only the H. So H is not thickness of the clay. H is the thickness of clay which is under compression, which means below the load. And if you know the liquid limit, you can find out the CC, compression index. If you know the water content and specific gravity, you can find out the initial void ratio. And you're going to find out the effective stresses, which is nothing but sigma naught dash, that is initial overburden pressure. Initial overburden pressure. So this is known as with respect to self weight, and delta sigma dash, this is nothing but increase in effective stress due to external load. So we are going to use either 2 vertical to 1 horizontal distribution or Bosnius theory to find out those, and we can find out. And mind you, this sigma naught dash and delta sigma dash should calculate at center of the compressible clay layer. At center of the compressible clay layer. Right. So this is one model where they will be asking, if you see in the previous gate, at least 4 to 5 questions has been asked based upon the 2 marks question, based upon this topic itself. And next one is time rate of settlement. Time rate of settlement. The time rate of settlement is, if you construct a building and if that building got settled by some certain settlement in certain time. Suppose if the building got settled or soil got settled by 5 centimeters in 4 years, what would be the settlement at the end of 9 years? Or what would be the time required to cause a settlement of 10 centimeters? Means, if you know for a given time for a given settlement, what is the settlement for the other time, or what is the time required for the other settlement? So that is known as a time rate of settlement. And for the time rate of settlement, we have 2 equations that was given by the Terzaghis one-dimensional theory, one-dimensional consolidation theory. Those solutions are, one is time factor, TV is equals to CV into T by D square, where C is nothing but quotient of consolidation, T, time of the consolidation, D is nothing but the drainage path, which depends upon the single drainage or double drainage. And one more solution is the degree of consolidation, which is S by SF into 100. Settlement at any time by ultimate settlement. Again, this ultimate or maximum settlement will be utilized over there. Or there is one more formula for the degree of consolidation with respect to excess pore water pressure. UI bar minus U bar by UI bar into 100. UI bar means initial excess pore water pressure. When you apply an external load on a fully saturated soil mass, immediately the entire pressure that you applied will be taken by water and develops as excess pore water pressure. And with the time, during consolidation, as water goes out, the excess pressure decreases. So, in simple words, the degree of consolidation is how much excess pore water pressure decrease in terms of percentage. Initial and after some time U bar, this much is decreased out of the UI bar. So, this is how you are going to find out the degree of consolidation. TV is equals to CV into T by D square, and this is the degree of consolidation. Okay, and in order to get down the relation between the TV and U, a relation between time factor and degree of consolidation. What are the relation between the time factor and degree of consolidation is, as long as the degree of consolidation is less than or equals to 60%, the time factor TV is equals to pi by 4 U square. And whenever the U greater than 60%, then the time factor TV is 1.781 minus 0.933 log based on 100 minus U in terms of percentage. So these are the 2 models where they will be asking more number of questions. I mean, I'm saying you the applications of these concepts will be keep on asking. And for the 1 mark question, they'll be asking, like for single drainage 4 years, for double drainage, what is the time? For the single drainage 4 years, for the double drainage 1/4. Whenever there is a double drainage, the drainage path will decreases. When drainage path decreases, time also decreases. How much? Always the time required for single drainage is 4 times of the time required for the double drainage. Given that thickness is same. Given that thickness is same. Okay. So these are the some of the concepts where in the previous consolidation topics they are asking. And if you see, in the case of the shear strength, majority of the questions they are asking from the triaxial test. So they'll ask a majority of the questions from the triaxial test, and that is the equation, plastic equilibrium equation, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. Majority of the questions they will be asking from based upon the plastic equilibrium condition. So where sigma 1 is a major principal stress, sigma 3 minor principal stress. In the case of the triaxial test, there are 2 stages, consolidation stage and shearing stage. In the consolidation stage, we apply the cell pressure. In the shearing stage, we apply the deviatoric stress, which is nothing but sigma. The sigma 1 is nothing but sigma c plus sigma df. So they can ask you lots and lots of questions. In the triaxial test, there are different type of tests whereas UU test, CD test, and CU test. And we have various results also. In the case of this triaxial test, in the case of UU test, unconsolidated undrained test, phi u is equals to 0 degrees. And you substitute phi u as 0 degrees over there, then alpha f is 45 degrees. Then Cu will become as sigma 1 minus sigma 3 by 2, which is Cu is equals to deviatoric stress at failure by 2. In shear strength topic, they ask more number of questions from the triaxial test. And from the UU test, Cu is half of deviatoric stress. And if you see CD and Cu tests on NCC soil, on the NCC soil. Cu and CD tests on the NCC soil. In this case, C value 0 and phi value is equals to sine inverse of sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Whereas in CD test, that is effective stress analysis. And Cu test, that is effective stress and total stress analysis. Both has to be considered. In the UU test, that is effective stress, total stress analysis, which is nothing but phi u Cu. If I say the CD, these are C dash and phi dash. If I say that is Cu, the sigma dash, that is the Cu phi u and C dash phi dash also. This topic is very, very important in the case of the triaxial test. And in the case of the triaxial test, again, they may be asking in UCS test, unconfined compressive strength test, where the unconfined compressive strength is nothing but 2 Cu tan alpha f. In the case of the clays, again, phi u 0 degrees, alpha f 45 degrees, then the cohesion is nothing but half of the unconfined compressive strength, right? The logic is whatever the Cu in UCS test is the same as the Cu in the UU test. Cu, half of the deviatoric stress. Here the deviatoric stress is additional stress. But in the case of the UCS test, there is no cell pressure, which means sigma 3 is 0. Sigma 1 is sigma df, which is nothing but the unconfined compressive strength. So from these two tests only, lots and lots of questions has been asked. And in the recent years, they're asking a more number of questions with respect to the stress path. So what is this stress path? This is nothing but the locus of the stresses, locus of the maximum shear stresses, locus of maximum shear stress point. Maximum shear stress points up to locus of the maximum shear stress points till failure. Okay. So now if you observe, if you take any Mohr circle, this is a failure Mohr circle. And for this failure Mohr circle, you can see the maximum shear stress point. This is P comma Q, where P is x ordinate and Q is the y ordinate. The P is nothing but sigma 1 plus sigma 3 by 2, and Q is nothing but sigma 1 minus sigma 3 by 2, because P is nothing but the normal stress at maximum shear stress and Q is the maximum shear stress. For different loadings, sigma 3, sigma 1, you find out P, you find out Q. For different loadings, if you find, and if you draw a line with a P on x-axis and Q on y-axis, P on x-axis and Q on y-axis, this line we call it as a KF line, which is a modified failure envelope. This is a modified failure envelope, and whatever the angle made by this line is a psi, and whatever this is nothing but the d. From this equation, this is known as you can observe that is the equation of a straight line having some intercept d. Now if you observe here, there is going to be Q is equals to d plus P into tan psi. That's the equation of the modified failure envelope. That's the equation of the modified failure envelope. See, earlier the questions would be asking based on triaxial test and usage test. In the previous years, they're asking about the stress path also. And from here, the D value is C cos phi. So there is some derivation for getting this one. Comparison of the modified envelope to the standard envelope. And the tan psi is equals to sin phi. So this is how we are going to find out the C and phi. See, whether it is a triaxial test or whether it is usage test or stress path, our main aim is to find out the shear strength parameters. If you know the shear strength parameters, then you can find out the shear strength, which is nothing but tau f is equals to C plus sigma into tan phi. And that stress path is nothing but the stress path is nothing but the locus of the maximum shear stress points till failure, right? So how the failure is happening? How the failure is happening? Okay, so that is going to be mixed up, and we are going to see over there. And these are the different type of models that you can expect in the shear strength topic. So here itself, S is equals to C plus sigma into tan phi. So that's about the consolidation topic, permeability, what are the different type of questions. You see the previous gate questions, majority of the questions. See, I cannot give you each and every point, but where they're asking more number of questions, I can frame it over here and I can let you know. And then we discussed about in the case of the earth pressure theories, in the case of earth pressure theories, if you see the earth pressure theory, in case of the earth pressure theory, the type of questions one can expect in the recent times is, so first one is critical height or unsupported depth of excavation. This is one of the questions that is frequently asking. Unsupported depth of excavation. So this topic, like we can see that critical height is nothing but 2 times of ZC. And if there is no surcharge, that ZC is equals to 2C by gamma root Ka. And if there is a surcharge, then this is going to be 2C by gamma root Ka minus Q by gamma. So this is without surcharge, and here it is with surcharge. And more frequently asking questions, one is critical height or unsupported depth of excavation. And number two is, we know there are 3 states. So states of the soil, that is nothing but the at rest condition, active state, and passive state. At rest condition, active state, and passive state. So in the case of the at rest condition, if you take the K0 value for the cohesionless soils, K0 is 1 minus sin phi. Here Ka is 1 minus sin phi by 1 plus sin phi, and Kp is 1 plus sin phi by 1 minus sin phi. So in the case of the C5 soils, the Pa is equals to Ka into sigma V minus 2C root Ka. Pp is equals to Kp into sigma V plus 2C root Kp. The other type of models that one can expect from the earth pressure theory in the recent years is, they will give you a retaining wall. They will give you a retaining wall like this, and they will mention you either a homogeneous soil deposit. This is a retaining wall of height h. They will give you the soil deposit as a backfill, whether it is a homogeneous or anisotropic. If it is anisotropic, it has a different property C1, phi1, gamma 1. It has another property C2, phi2, gamma 2. So if it is isotropic, all the properties are same. Whether it is a homogeneous or anisotropic soil, they will give you. What they will ask you is, what is the maximum pressure acting on the wall? Where does the maximum pressure acting? You know the variation, the stress variation will happen from top layer to the bottom layer. So maximum, this is the maximum earth pressure. The maximum earth pressure acts at the base of the wall. Maximum earth pressure. So this is the maximum earth pressure. They're asking find out the maximum earth pressure. And when they give the question, they'll mention that if the wall is restrained against the yielding, if the wall is restrained at top, if the wall is restrained at top means fixed at top, then it is nothing but the at rest condition. That's nothing but the at rest condition. And if the wall is free to rotate, majority of the ordinary retaining walls, they will rotate by means of active state. So if they mention free to rotate, always you use that as an active state. And you know the Ka value and you know those equations. So if they ask you the pressure, you can find out the pressure. And while doing so, you have to understand that this is a different layers. This is layer 1, this is layer 2. At layer 2, which properties I have to use? Layer 2 properties I have to use. And one more question you can expect is to find out the force. One is pressure, another one is a force. But in order to find out the force, you need to first draw the pressure diagram. Once you draw the pressure diagram, then due to cohesion, there is a one crack known as a tension crack. You have to remove the tension zone. If the crack formed, you have to remove the tension zone. Whatever the remaining pressure diagram, the area of the pressure diagram is nothing but the force. So you can ask, you can expect a question based on the critical height or unsupported depth of excavation, and you can you can get a retaining wall and where they're asking about what is the maximum earth pressure. You can get what is the active force or passive force or at rest force acting on the wall, and you can ask what is the depth of the tension crack. So these are the models that one can expect from the earth pressure theories. And similarly, next. If you see the bearing capacity chapter, bearing capacity chapter. In the case of the bearing capacity chapter, the majority of the questions that you can expect is from the Terzaghis bearing capacity theory, and then Meyerhof theory also. In 2023 also we got a question based on the Meyerhof theory. So the Terzaghis equation, bearing capacity theory, the Terzaghis equation, Terzaghis theory. In the case of the Terzaghi theory, for the strip footing, Qu is equals to CNC plus gamma dnq plus 0.5 gamma b and gamma. That is for the strip footing. And if you see that CNC is nothing but the cohesion effect, this we call it as a cohesion effect. This we call it as a cohesion effect. And what about this gamma dnq? This we call it as a surcharge effect. And this one we call it as a width effect, right? So in the case of the Terzaghis theory, the QU, CNC, cohesion effect, surcharge effect, and width effect. So if you observe in the case of the bearing capacity, the Terzaghi theory, now based on the type of the soil, if the soil is cohesionless soil, C is 0. If the soil is cohesive soil, for cohesive soils, and you know this NC, NQ, N gamma are bearing capacity factors that depends upon the phi, right? And in the case of the clay, for clay, phi is equals to 0 degrees. And what is NC value? 5.14. This is as per the Prandtl. Even Meyerhof also uses as a 5.14 only. Meyerhof uses the Prandtl's NC value. Meyerhof uses the Prandtl's NC value. That was the question asked in GATE 2023. They asked 2 marks numerical question. Asked, they give you the clay soil, but the theory is based on the Meyerhof. Based on the Meyerhof, the Prandtl and Meyerhof, they use same NC 5.14. 5.7 is for the Terzaghi. And NQ is equals to 1 and N gamma is equals to 0. When N gamma is equals to 0, that is nothing but width effect is going to be neglected. In clays, ultimate bearing capacity is independent on the width effect. If I say soil is cohesionless, then cohesion effect will be gone. If I say the footing is on the surface, then surcharge effect is going to be gone. So based on the given question, you have to understand whether it is a cohesionless soil or cohesive soil, whether it is at the surface or below the surface, whether they are asking with respect to Meyerhof theory or Terzaghi theory. And for the different footings, in the case of the different footings, in the case of the square, the QU is just a modification 1.3 CNC plus gamma DNQ plus 0.4 gamma B and gamma. That is for the square. And in the case of the circle, the ultimate bearing capacity is 1.3 CNC plus gamma DNQ plus 0.3 gamma B and gamma. And in the case of the rectangle, the QU value is 1 plus 0.3 B by L CNC plus gamma D and Q plus 0.5 into 1 minus 0.2 B by L gamma B and gamma. So these are the various equations that has been given for a different type of footings as per the Terzaghi's theory. So but what are the type of questions that we can expect is, we can expect as design questions. They can ask you the points as the design criteria. The design criteria, so by giving the data, the examiner may ask you, find out the width of the footing, means B. Find out the depth of the footing, means D. Find out the factor of safety, F. Find out the load carrying by the footing, net load or gross load. Once you know the QU, then the design criteria is the safe bearing capacity. Whatever the gross pressure Q must be less than or equals to safe bearing capacity, or net pressure must be less than or equals to the net safe bearing capacity. And the safe bearing capacity is nothing but net safe bearing capacity plus gamma D, which is net ultimate by factor of safety plus gamma D, which is ultimate minus gamma D by factor of safety plus gamma D. So this is a design criteria. Based on the design criteria, we have to find out to determine that condition we use to determine width of the foundation, depth of the foundation, factor of safety, net load or gross load. Anything you want to find. Anything you have to find. You want to find a width, depth, factor of safety, net load or gross load, you have to apply that condition as the design criteria. Whatever the data they give you, based on the data, you need to substitute the ultimate bearing capacity. You have to check whether the given footing is a strip footing or square footing or circular or rectangle. And once you know that, then whether they give you the net load or gross load. If they give you net load, net pressure must be less than or equals to net safe bearing capacity. And if I give you the gross load, and you have to take it as a gross pressure must be less than or equals to gross safe bearing capacity. And in order to design the width, the depth, the factor of safety, net load and gross load, we have to use this condition. This is from the Terzaghi. And there are two more theories which we know it as a Skempton's theory. The Skempton's theory, in the case of the Skempton's theory, this is majorly suitable for the clays only, where QNU is equals to CNC, and that NC is equals to 5 into 1 plus 0.2 D by B into 1 plus 0.2 B by L. This is for the rectangle. This is for the rectangle. And NC is equals to 6 into 1 plus 0.2 D by B. This is for the square. And NC is equals to 5 into 1 plus 0.2 D by B. This is for the strip. So that is only suitable for the clays in the Skempton's theory. If they do mention the Skempton theory, then only you go for the Skempton's theory. And in the case of the Meyerhof theory, This is valid for both shallow and deep foundation. In the case of the Meyerhoff theory, the ultimate bearing capacity is cohesion effect plus surcharge effect plus width effect. These are all just like Terzaghis theory only. Just like Terzaghi theory. But Terzaghi said this one only for the strip. Remaining, we have to consider the different equation. Whereas the Meyerhoff did one thing, instead of going for different equations, I'll give some factors to consider the shape. That is known as SC, SQ, S gamma. Terzaghi considered only the vertical loads, not the inclined loads. To consider that inclination IC, IQ, I gamma. And Terzaghi mentioned whatever the footing is a shallow footing because Terzaghi theory is based on soil fails by general shear failure. But foundations can be failed by general shear failure, local shear failure, punching shear failure. So that can be taken into the consideration by means of the depth factor DC, DQ, D gamma. And in the case of the Terzaghi, whatever the discussion that we make, this is for the general shear failure where phi value is greater than 36 degrees. And if a phi value is less than 28 degrees, then it is a local shear failure. Then you have to use C as a Cm, which is 2/3 of C, phi as tan phi m, this is known as a 2/3 of tan phi. 2/3 of tan phi. So in the case of that equation, equations are same, but instead of C, we have to use it as Cm. Instead of phi, we have to use it as a tan phi m. So these are the models that one can expect from the Terzaghi's theory. See, I'm telling you in the stipulated time, I'm not giving you the whole, I'm giving you the major thing, the major core. If you can understand, the remaining things you can formulate. Hope you understand. And now let's last topic, that is known as a pile foundation. In the case of the pile foundation, in the recent years, from the pile foundations, they're asking more number of questions from the under-rimmed piles. They're asking questions from the uplift or tension piles. In the recent years, more number of questions on the under-rimmed piles. More number of questions on the under-rimmed piles, comma, negative skin friction. More number of questions from the negative skin friction, uplift or tension piles. So these are topics where they're asking frequently in the previous chapter. So under-rimmed piles, negative skin friction and uplift or tension piles. In the case of the under-rimmed piles, so if this is an under-rimmed pile, this is the bulb portion and this is the bottom. And in the case of the under-rimmed pile, when you apply the load, the compressive load, there will be a resistance on the sides as a skin friction, and there will be resistance at the bottom, and there will be one more resistance at the bulb portion, QEB. This is a QS. And let's say the X is a length of the bulb and total length is L. In the case of the under-rimmed pile, the ultimate load carrying capacity of the pile is skin friction plus bearing resistance plus the bearing resistance at the bulb. So if you see that QU, basically the under-rimmed piles are provided in the case of expansive soils, which means that soil is definitely a clay soil. We don't go for the under-rimmed piles in the sands. We go for the under-rimmed piles in the case of the clays only. So in the case of the clays, the skin friction is alpha into C bar into pi d into L minus X, because skin friction develops along the length. And where there is a bulb, in that X portion, you don't see that, and remaining portion you are going to see L minus X. So alpha into C bar into pi d into L minus X plus QB, which is nothing but the bearing capacity. So if dB is the dia of the bulb and small d is the dia of the pile, dB is dia of the bulb and small d is the dia of the pile, then if you observe the end bearing capacity, that is nothing but the QB, which is pi by 4, okay. That is about the shaft. So whatever the cohesion at the bottom, CNC into pi by 4 d square, I am writing d square, plus What about that QEB? The QEB is nothing but, there must be some quotient in the bulb portion. Let me take that as a C dash into NC into pi by 4 into dB square minus D square. See, that is going to be happen only in the outer portion, right? So we have to take the outer area only. Outer area, pi by 4 dB square minus D square in that. C dash into NC, where C bar, that's average over L minus X. C dash, that is in the X portion. C, which is known as the quotient at the pile tip. Okay, for homogeneous soils, C bar is equals to C is equals to C dash. Okay, so these are the things that we need to know in the case of the homogeneous soils. And tomorrow we'll be taking a one session where we'll be discussing about the important topics and questions. There I'll be taking the topics of the negative skin friction, uplift or tension piles, and some other topics. So as I'm going to discuss that elaborately in the tomorrow session about the negative skin friction and uplift or tension piles, we'll see those questions in tomorrow's session. So whatever the data that I have given you, the more number of data means it covers majority of the 2 marks questions that are applied. In a span of just 1 hour, we were discussing about all these things. Okay. So I hope this session was engaging to you. This session is important, and if you feel so, let us know. So that's all with this session, and I'm concluding this session. And this is not the end. Tomorrow one more session is there where we will be discussing about one topic, and we'll be discussing about some questions elaboratively with the topic only. Okay. So till then, take care. Bye bye.